All right, so welcome to this next video. In the last video, we were talking about vertical asymptotes. In this next video, we are going to be dealing with horizontal asymptotes. In short, all right, that is HA. And just to remind you what that looks like. So normally if you've got a function in the X and Y Cartesian plane, and you just have an asymptote in that line, so y equals to whatever the L value is, that is a horizontal asymptote. It is a line that the graph doesn't touch. But before we do that, I want to get into the definition of how do we define a horizontal asymptote. So actually, if the limit as x goes from either positive or negative infinity, you can choose positive infinity for our purposes. That will suffice. If the limit as x tends to positive infinity of f of x gives us a number L, we say that the horizontal asymptote is given by the equation y equals to L. That's what the horizontal asymptote gives us. And just another reminder, remember that when you are taking infinite limits, for our syllabus, we can deal with just the positive infinity. And therefore, if you take the limit of 1 over x to the n, that will give you 0 every single time. So that is quite important for you to remember. So let's dive deep into this. And in our questions now, we will say determine the horizontal asymptote instead of determining the vertical asymptote. So determine the horizontal asymptote of the following functions. So let us dive deep into this. So let us see. So if we were to do this, what we have to do is to take the limit as x tends to infinity of this expression 2x plus 1 over x. So in this case, we know that the limit as it goes to infinity of 2 is just 2. And according to our definition at the top, if I've got 1 over x, this is to the 1 or to any power that gives us 0. So from this, we are able to say that this particular limit is 2, and therefore the equation of the horizontal asymptote will be given by y equals to 2 of this function. And that's exactly what that means. Let's tackle more questions on this where we're doing infinite limits. This is a good reminder to do that. So let's dive deep into this one. So the limit as x tends to infinity. So remember, we can simplify these expressions by dividing by the highest power that we have. So this will be x over x, and this will be 1 over x. And we can clearly see that by division of this, we still have the limit as x tends to infinity. But now it will be the infinite of 2 over 1 minus 1 over x. So according to our definition, this is the only part that's going to be zeroed, and therefore we are left with 2 over 1. And what that means is that the equation of the horizontal asymptote is 1, y equals to 2. Let us deal with more equations now. Let's come back to this one here. So we'll come and deal with the limit as x tends to infinity. The highest power we have is 2, so we will divide everything by that. Let's do that quickly. Over, we have 2x squared over x squared minus x over x squared minus 3 over x squared. And we still have the limit as x tends to infinity of that. So we know that the first part is going to give us 1 plus 2 over x plus 3 over x squared all over 2 minus 1 over x. And in the denominator, it'll be minus 3 over x squared. And according to our definition of the infinite limit, that'll be 0, that'll be 0, that'll be 0, that'll be 0. And hence we left with y over 2. And therefore the equation of our horizontal asymptote will be given by y equals to 1 over 2. I'm hoping this is starting to make sense. And when you do apply this into functions, you will see how it applies quite nicely. Let's come back to this one again. we'll go the limit as x tends to infinity. The highest power we have is x over 3. So we will divide by x over 3, x to the power 3, 5 over x to the power 3, plus 3x to the 3 over x to the power 3. So from there, we continue to take our infinite limit. And then we know that this will give us 4. This will give us 3 over x squared. And this will give us 5 over x to the 3. And this will give us 3. And by definition of the infinite limit, this part is going to be 0. That part is going to be 0. And hence, our final answer becomes 4 over 3. And hence, the horizontal asymptote of this will be given by y equals to 4 over 3. So let us do the last question here. So in this case here, we'll do the infinite limit. And this, the highest power we have is 2 to the 3. So this will become 2 over x to the 3 plus x over x to the 3 minus 4x to the 3 over x to the 3 divided by 5x to the 3 plus 3x squared over x to the 3. And I think we can simplify that for ourselves now. We still take the infinite limit going in that direction. This is 2 over x to the 3 plus 1 over x squared minus 4 over 5x to the 3 plus 3 over x. So according to our definition again, this will be 0, this will be 0, this will be 0, this will be 0. And our final answer for this becomes minus 4 over 0. But we know that this is completely undefined. So if this is undefined, it means that we have no horizontal asymptote. And I hope that this makes sense. So when it comes to the idea of the horizontal asymptote, this is how we are able to do it. In the next video, I'll dive into the next type of asymptote. And hopefully that will put everything all together. And then once we've done this, we'd have covered all the asymptotes. And therefore, we can begin sketching functions with asymptotes. So see you in the next video.